Welcome back to AI on AI, the show where we dissect cutting-edge research so leaders and technologists can build the future. Today, we're unpacking Beyond 10 Turns, the ASearcher project.
Delighted to be here. My background's corporate strategy, and this paper screams competitive edge for any knowledge-hungry enterprise.
Hey folks, I'm a systems engineer who's wrestled with distributed RL clusters. The async bits in this work had me nodding hard.
And I focus on data generation pipelines. Honestly, their autonomous QA synthesis agent is a data nerd's dream.
I handle RL algorithm design, so GRPO and the decoupled trajectory logic are right up my alley.
I'm product side, integrating search and browser tools into consumer applications, and I've got war stories about latency budgets.
Fantastic lineup. Let's start with the headline. Why does Beyond 10 Turns matter beyond academia?
Well, put simply, long horizon search unlocks answers no standard LLM or overworked analyst could dream of. Imagine a pharma company triaging tens of thousands of research papers overnight.
Exactly. Our retail clients struggle when product metadata is messy. Multi-turn search lets an agent untangle conflicting SKUs just like it resolved that Olympic medal count dispute in the paper.
And that's possible only because the agent isn't shackled to a 10-turn leash. We're talking 40-plus tool calls and up to 150K generated tokens during training. Wild scale.
Right, but scaling comes at a cost. Synchronous rollouts stall GPUs. Their fully asynchronous engine removes that waiting for the slow kid bottleneck. Think of it as replacing a single-lane toll booth with EasyPass.
They use the insight that variance in trajectory length follows a heavy tail distribution, Pareto all over again, so decoupling rollouts from updates keeps throughput near peak capacity.
Love the toll booth analogy. Let's zoom into the tech. What exactly is this asynchronous Agentic RL, and how does it differ from one-step off or standard PPO loops?
In a vanilla PPO setup, you gather end trajectories, compute advantages, then update. One slow trajectory stalls the batch. ASearcher instead streams trajectories into a queue. As soon as a mini batch meets the size criterion, an update fires. No global barrier.
They implement what I'd call double decoupling. 1, actor threads spin up independent tool calls. 2, learner threads read from a shared buffer. This way, a 70-call monster episode doesn't choke the cluster.
And because the agent's generating lengthy web summaries, token generation time dwarfs network latency. The learner never waits for the summarizer.
For the business folks listening, why should you care if an agent has 128-step turn limits?
Longer horizons mean the agent can handle ambiguous multi-stakeholder queries. Picture an insurance company auditing claims across medical records, legal precedents, and customer emails. The depth mirrors a 128-turn dialogue.
Plus, fewer escalations to human operators. One of our pilots in legal compliance saw a 40% drop in analyst intervention after we upped the turn cap.
That's huge. Now the data synthesis agent, what makes it special compared to, say, scraping Stack Overflow?
3 words: injection, fuzz, validation. It starts with seed questions, injects tangential facts to raise complexity, fuzzes key terms to raise uncertainty, then runs a multi-stage QA filter.
Quick sidebar, fuzz here isn't random noise. It strategically obfuscates entity names. Example, swap Catskill Mountain Railroad for a historic mountain railway.
The twist is they run difficulty gating. If QBQ32B answers it without tools, it's discarded. That forces genuine tool use learning.
Which, from a market standpoint, is a barrier to entry. You're not just fine-tuning on old hotpot QA, you're building IP around task-specific, high-uncertainty data.
Classic moat. Any heuristics you noticed, like the 80-20 rule in action?
Definitely, roughly 20% of synthesized QAs drove about 80% of the reward signal, especially those requiring cross-document inference.
And on training, about 20% of trajectories accounted for most compute overhead, hence the need for async.
Let's deep dive into the GRPO algorithm they used. How does it differ from PPO, and why is it better for text?
GRPO, or Grouped Reparameterized Policy Optimization, computes relative advantages across a batch of generated answers for the same prompt. It stabilizes updates when reward variance is high, a known challenge in language tasks.
Put another way, each question forms its own mini arena. Only the best answers get reinforced, reducing catastrophic forgetting.
Plus, it's token-level clipping, so suboptimal partial responses aren't entirely thrown out.
Now, contrarian moment. What's the catch?
Everyone's celebrating efficiency, but we're missing the real bottleneck: browser tool latency. When embedding this in customer-facing apps, that 40-turn chain can exceed user patience.
Yup, UX designers panic when load wheels spin. One mitigation we tried was speculative search. Fire off parallel searches for top K candidate queries, then prune.
That's doable, but raises token costs. There's no free lunch. Herb Simon's bounded rationality applies. Optimize under resource constraints. Famous quote time. Abraham Lincoln once said, "Give me 6 hours to chop down a tree, and I will spend the first 4 sharpening the axe." How does ASearcher sharpen its axe?
The synthesized dataset is the sharpening, preparing the agent so online RL focuses on edge cases rather than basics.
And the asynchronous architecture is like adding multiple sharpeners working in parallel, so the blade stays keen during training.
Let's talk real-world deployment. Any pilot stories?
We integrated a trimmed-down 7B variant into an e-commerce catalog curation tool. Accuracy on ambiguous product merges jumped 18% after RL training versus a vanilla Search 01 prompt stack.
In financial services, a hedge fund's research desk used an early build to vet ESG controversies. The agent cross-referenced NGO reports, news, and filings, reducing manual verification cycles by about a third.
And in healthcare, radiologists used it to surface conflicting guidelines. The long horizon let it trace citations through 3 hops of medical literature. That cross-domain versatility is compelling. Shifting gears, security and hallucinations. How does extended turn count affect risk?
More turns mean more chances to hallucinate, but also more opportunities for self-verification. ASearcher explicitly allocates turns to grounded verification, an action tag that triggers fact-checking.
Training rewards penalize unsupported claims. The agent learns uncertainty-aware reasoning, listing candidates, then narrowing.
For compliance, we still layer a guardrail LLM in a sandwich architecture, agent output, policy filter user, but the false positive rate decreased post-RL.
Interesting. Could smaller orgs replicate this, or do you need hyperscaler GPUs? The team clocked 7.6K H800 hours for the 32B run, but the 7B and 14B models trained with smaller clusters. You can approximate with consumer-grade A100s if you drop turn caps to, say, 64.
And remember, value scales non-linearly. Sometimes the 14B with good domain data outperforms a generic 32B.
Speaking of domain data, could the synthesis agent incorporate proprietary corpuses?
Absolutely. Seed QAs from internal documents, then inject public facts. Important to maintain a clean lineage graph for IP audits.
We did a private alpha with legal contracts. We fuzzed clause numbers and injected case law, all kept in a secure enclave.
Let's tackle evaluation. F4 pass F4. Why should the boardroom care?
Every F4 simulates an engineer reading 4 suggested answers and picking the best. Pass F4 tells you the probability the correct answer is in that shortlist. Think top-of-funnel quality.
In a help desk context, passing at 70% means fewer ticket escalations. That's real OpEx savings.
I sense some friendly disagreement brewing. I'd argue latency matters more than pass F4 at times. Users abandon when response times exceed 8 seconds.
True, but asynchronous rollouts can pre-warm caches. Prefetching page summaries cuts weight by half. Saw it in our A/B test.
And don't forget caching embeddings of common queries. Amortize token generation.
Great back and forth. Let's insert our element of surprise. Any unexpected insight from implementation?
Honestly, The model learned to self-censor dubious inferences before we added an external filter. Reinforcement feedback implicitly taught epistemic humility, didn't expect that emergent property.
That's fascinating. Could become a selling point. Built-in skepticism.
Final technical deep dive, token budgeting. 150K tokens per trajectory during training is massive. How's that viable? They chunk summaries and keep only the latest 25K chars in context for QWQ. Older info is distilled into compact thought messages. Think of it as rolling lossy compression.
Plus, summarization itself is RL optimized, so the agent learns to write concise notes, kind of like an overachieving intern taking better minutes every iteration.
On inference, we enforce stricter limits, stream summarization back to the user as incremental thoughts, keeps UI responsive.
Let's wrap with future directions. What excites you most?
Domain-specific deployment. Imagine tax law or biotech literature where ambiguity is rampant.
Technically, mixing asynchronous RL with speculative decoding could slice latencies even further.
I want to extend data synthesis to multimodal, inject images or tables, fuzz them, then train agents to use vision tools.
I'm eyeballing hierarchical RL, macro-level planner, micro-level executors.
And I see subscription-based search intelligence as a service. Teams rent an agent, not an LLM.
Quote to end on. Peter Drucker said, "Efficiency is doing things right. Effectiveness is doing the right things." ASearcher seems to chase both. Thanks to all our experts and to our audience. Go sharpen your axes and explore long horizon search. Until next time, stay curious. All right, welcome to part 2. Grab a coffee, because now we'll roll up our sleeves and walk through the nuts and bolts of implementing an ASearcher-style system in production. Perfect. Let's start at the bottom of the stack, hardware and orchestration. In the paper, they used H800s, but a lot of shops can replicate the async pattern on 8A100s managed by Kubernetes with Array Cluster. The key is isolating actor pods from learner pods, so node failure doesn't wipe your replay buffer.
Building on that, the learner keeps a circular FIFO buffer. Think of it like a DVR that always records the last 100K trajectories. Each entry stores token counts, tool use metadata, and a sparse terminal reward. The GRPO update thread then samples by query ID, so advantages are computed within homogeneous groups.
And don't overlook tokenizer throughput. 150K tokens, a trajectory is pointless if your tokenizer thread is single core. We offloaded sentence piece to a small Rust sidecar, tripling throughput before it even touches the GPU.
Hardware talk aside, product managers need service-level clarity. We found that pinning actor pods on the same node as a lightweight search microservice shaved roughly 25% off call latency, even on consumer hardware.
Nice, but how does the reward pipeline look in practice? Sparse terminal rewards scare folks worried about credit assignment.
The trick is reward shaping without leaking the answer. We stitched in a format validator that gives plus 0.1 if the JSON answer schema is intact, plus 0.2 if the agent cites at least one URL, then the big win or loss when LASJ confirms factual correctness. That small dense strip keeps the policy gradient signal alive.
Exactly. It's like Pavlov treats before the steak dinner. Those micro rewards stabilize early learning so the model doesn't spiral into degenerate loops.
For executives, think of it as progressive KPIs. First, the agent learns etiquette, then compliance, finally insight. It's no different from onboarding a junior analyst.
On the data gen side, the synthesis agent runs in 3 phases: seed load, iterative transform, triage. Implementation-wise, we used an Airflow DAG. Step 1 pulls seed QAs. Step 2 spawns 8 fuzz workers and 8 inject workers. Step 3 pushes outputs into a validation queue, where a smaller 7B model filters egregious off-topic samples.
A quick hack we added: Bloom filter deduplication on question strings. Without it, the queue swells with near duplicates and drives up RL variance. That saved us 30% storage.
Let's surface a business example with those implementation choices.
Sure, a logistics company used the injection step to insert port-specific regulations into routing questions. The agent then simulated custom scenarios, cutting planning cycles by a reported double-digit percentage. That came straight from fusing proprietary CSV data into the synthesis pipeline.
And from the technical side, adding that proprietary dimension only required one extra column in the Airflow schema. Low engineering overhead, high strategic gain.
Don't forget the contrarian angle. Bigger isn't always better. We ran an ablation where we chopped the history window from 25K chars to 10K, but inserted a retrieval cache keyed by semantic hashes. Same accuracy, 40% less memory.
Yeah, people obsess over context length, but retrieve then distill beats stuff it all in. The 80-20 rule again. 20% of the context holds 80% of the signal.
How about the technical debt others might hit?
Logging. With fully async actors, logs arrive out of order. We used vector clocks embedded in log lines so Kibana can reconstruct sequences. Miss that, and debugging a stuck agent feels like playing 4D chess blindfolded.
And checkpointing. Save both policy weights and replay buffer indices. Otherwise, after a crash, you'll reload a policy that expects trajectories you no longer have, and training diverges.
All this matters to leadership because unrecoverable crashes translate to downtime, and downtime erodes trust. The bitterness of poor quality remains long after the sweetness of low price is forgotten, as Aldo Gucci said, and that applies to rushed ML infra too.
Let's wrap with a future-proofing angle. What's one implementation tweak you'd recommend for teams starting today?
Integrate a lineage graph. Store which synthesis action created each question. It simplifies GDPR deletion and audit trails.
Swap the static turn cap for an adaptive budget estimator. A small controller LLM can predict how many hops a query needs and allocate tokens dynamically. Saves compute.
I'd containerize browser tools with secure enclaves, prevents data exfiltration, and eases ISO audits.
From the product lens, expose confidence bands to users. If the agent lists multiple candidates, surface them. Transparency beats false certainty.
And strategically, modularize every component, the search wrapper, the RL engine, the synthesis DAG, so acquisitions or partnerships can plug right in without full re-architecture.
There we have it, a blueprint from silicon to C-suite. As Sun Tzu wrote, victory comes from finding opportunities in problems. ASearcher's Async RL is one such opportunity. Thanks everyone, and to our listeners. Deploy wisely, iterate relentlessly, and we'll catch you on the next episode of AI on AI.
Quick headline recap from the engineering chair. Fully asynchronous rollouts decouple actor latency from learner throughput. GRPO with group-wise advantages stabilizes policy updates. And that Rust tokenizer sidecar still feels like cheating. It's so fast.
Totally. And marry that with dynamic token budgeting plus semantic hash retrieval caches, and you get a lean agent that can hit 40-turn horizons without melting the GPU wall clock. Call it latency-aware, long-horizon RL.
Implementation takeaway. If you can containerize search and browser microservices alongside actor pods, you squeeze out double-digit latency gains. That's pure margin for anyone running cloud GPUs by the minute.
From the product front, exposing confidence bands and lineage graphs isn't just compliance fluff, it's UX gold. We saw user satisfaction scores jump once they could peek into the agent's reasoning stack.
Strategically, the synthesis pipeline is the secret sauce. Own your domain-specific injections and you own differentiated intelligence. Think of it as building a proprietary moat, one fuzzed question at a time.
All right, key innovations. 1. Scalable async RL that kills idle GPU time. 2. Autonomous QA synthesis that keeps the agent sharp. 3. Reward shaping that balances etiquette with accuracy. And 4. Modular infra so business units can slot in domain data without tearing down the stack. Big business insight. Organizations adopting this pattern have sliced research cycles and planning loops by healthy double-digit percentages, not by throwing bigger models at the wall, but by orchestrating smarter workflows. Final thought. Whether you're holding the purse strings or writing CUDA kernels, remember the 80-20 heuristic we heard. Most of the value sits in a minority of context. Surface it, reason over it, and verify it. Thanks to all our experts and to you listeners. Iterate boldly, measure relentlessly, and we'll see you next time on AI on AI.